Hi, folks. Thanks for joining in. Hope you are doing great and most importantly, staying safe. I'm Prabhas Srivadana from WSO2, and this is our 33rd Silicon Valley IAM meetup. Today, we have Drummond Reed, who is the Chief Trust Officer at Evanim, and also he is a co-editor of the WTC DIT specification and a co-chair of the Sovereign Governance Framework Working Group. He also, at the moment, co-authoring the book Self-Sovereign Identity. And courtesy of Manning Publications, today we are giving away 3 copies of his book to the meetup registrants. So we'll share the codes to download the book via a meetup message. And also for everyone who is attending this meetup today, we are giving away a 35% discount code to buy any book from Manning for next 2 months. And we'll share that code via the YouTube chat shortly. Okay, so with that, I'll hand over to Drummond. Over to you, Drummond.
Thank you very much, Prabhat. It's a pleasure to be here. I'm going to be talking to you today about deeply about self-sovereign identity. Well, as deep as we can go. I'm going to share a presentation that covers sort of the whole space and specifically will build up to explaining the trust over IP stack that the whole SSI movement has generated. And it'll be in sort of like 5 or 6 chapters. So I'll stop at the end of each sort of section and we'll take questions and Prabhat will moderate that. So as you have questions as I'm going along, just you know, put them in chat or whatever is easiest, and then we'll stop, and we're not going to wait to the end because usually there are a lot of questions as when you have a technology as disruptive as this one for IAM. So let's dive into it. Again, as Prabhat said, I've spent pretty much my whole career. I actually was, believe it or not, a writer, and I was in the building business before I got into software. But then once I got into it, I ended up in this area of internet identity. If you're familiar with internet identity workshops, I've been to every one of them, all 30 over the last 15 years. The next one is next month, by the way, and it's virtual, just like this event has become. And so invite you to, if you find yourself really interested in this topic, definitely go to IAW. The virtual event's even more intense than the physical one. Worked on a ton of standards in the area, and that's what we'll talk about here is the standards for SSI. And I wear a bunch of different hats, and I think to this, to the relevance to this group is, the DID aspect, but also in addition to the Sovereign Governance Working Group at the Trustworthy Foundation, which I'll end with, we have a governance stack working group, and I'm also a co-chair there because the role of governance in SSI is increasing in importance. And okay, let's just dive into it. So at first, a high level, I want to make sure, I don't know who might be on the on the webinar that is not familiar with. It's like, why SSI and this thing called verifiable credentials? Why is it such a big deal? And the really short answer is that everyone, if you're at this meetup, you understand the various technologies we've used for digital identity and the whole move from centralized identity to federated identity and all the different flavors from SAML and early OpenID and OAuth and then OpenID Connect and FIDO. I mean, we've made a progression, towards broader and broader federation, and then, social login services, things like that. But all of them don't come close to emulating the way we actually do physical identity in the real world, right? And it's just, I have this picture of wallet and all the credentials in it because we all know how to do this. And we do it every single day in our lives. We're not traveling as much right now, but my favorite example is just going to the airport, getting on a plane, renting a car, renting a hotel room. We show credentials from the wallet. And if you just look at that simple model for how we do it, I love to say that's self-sovereign identity. What's self-sovereign is the wallet and your ability to control what credentials do you accept into it. You don't get any credential you want. You've got to actually qualify for them. But it's your choice to put them in the wallet, and then it's your choice where you take it and who you show it to, and no one is monitoring that activity. Why don't we have that in the digital world? And in a nutshell, SSI, verifiable credentials, that's what we're doing. It's really that simple. I mean, there's a lot behind it, obviously, and I'm going to go down to the details, but the core concept is just taking the way we've solved identity in the real world and moving it online. Now, what's behind that, and this is a diagram from the W3C verifiable credentials data model specification, which became a full finished W3C standard last September. So we are a year into it now of working on a 1.0 standard. And this trust triangle, I like to point out, is a trust triangle for all credentials, physical or digital, it doesn't matter. If you're going to convey trust through a credential, you have an issuer that issues credential holders. They keep it in some form of wallet or purse or whatever it is, whether it's physical or digital, and then they present the credential to a verifier, and it's the verifier's choice what they will accept. And the physical process, that we do, as I said, in travel every day, if we want to make that digital, obviously it's all got to be cryptography. The magic piece in the center is this, what they call, the specs call the verifiable data registry, and we use the same term in the DID specification. I'll talk about decentralized identifiers. And we'll go down into that in a minute, but really the trust triangle is the same in both ways. This is why it's just so intuitive. When you look at federated identity, it's not an intuitive model. You're inserting an intermediary everywhere you go to authenticate and share identity data. That's not how it works in the real world. There's some great spoofs out there you've probably seen on YouTube and other places about, folks following you around with looking over your shoulder at everything you do in the real world. It'd be absurd, but that's what is happening online. So here's the core of it. Now, I want to make sure this isn't abstract. And SSI, yeah, when we started, 4 years ago, this seemed like, really, are we going to do it? But I want to make it clear, verifiable credentials are out in the wild now. They are being issued. I want to use this particular example through today's presentation about COVID-related credentials. This is a CoinDesk article from April. They chose the unfortunate term immunity passport, and credentials about testing are somewhat controversial, both because of the science of testing and then the issues of, well, how long is it really good for, and is it going to be discriminatory if only people with smartphones are able to do this? And those are legitimate concerns around that. But there are other COVID-related credentials about which there aren't any concerns. For example, once we have vaccinations, having a digital credential is strongly bound to your identity that you've had a particular vaccination is going to be very valuable, and you're going to be able to get it in a physical form. If SSI didn't exist, you'd be able to do it with paper or plastic, but we're going to have it in a digital form. It's going to be much easier, faster, lighter weight to use, to issue, to revoke, and it's going to be stronger. It's going to be more secure and more private than the paper or plastic version. Now, there's another related credential to COVID, and it's the essential worker credential, and guess who needs it most? Healthcare workers. So the example I'm going to be using throughout this presentation is in production by the NHS, the National Health Service in England. They have nationalized health. They have doctors and nurses that need to move around between 2,500 NHS hospitals and healthcare institutions constantly and moving to COVID hotspots. The paperwork that they were processing for a doctor or nurse to move to another hospital and be authorized there is costing them 44,000 doctor hours per year. And if they move to what they call the digital staff passport, they thought they could bring that down to like under 1,000 hours of processing time. And so this credential, again, NHS accelerated their delivery. They did a pilot last year with Evernym, a company called Condatis, and Microsoft, and they proved it out. And then when COVID came along, they said, we need this now, and they accelerated the development. So this is in production now. In fact, NHS just did a huge hackathon last week based on this technology to explore all the other kinds of digital credentials that they're now in a position to start to use in their ecosystem. And I'm not going to give you any demos here or user experience, but I will just pop up and go. If you're wondering, well, how does it basically work? If you have used a mobile boarding pass on your smartphone, you have the basic idea. I'll talk a little bit more about the wallets we have on our smartphones today. They are, they're sort of early prototypes, but they are proprietary, wallets that are managed and you're locked into by the vendor of that smartphone. Where we're going here is open standard, something that's a lot more like a browser where you can pick the one you want to use and you can switch between them. That's what we're talking about. But the user experience needs to be similar to a browser. It's the same pretty much every place you go, with little tweaks in the wallet you're using. And it needs to be that way because you're engaging in security and privacy at the most important level. So the analogy Kim Cameron, the former chief of identity at Microsoft, he said, the ceremony of using digital credentials has to be like driving a car. It doesn't matter, you go to an airport, other side of the world, you get in the car, you better know how to operate it or someone's gonna get hurt. And so that's why we need these standard ceremonies. And as I said, you already know what the ceremonies are here because it's pretty much like a mobile wallet. So that's the end of the first chapter. I'm just gonna stop and ask, do we have any really high level questions before I dive down into how this stuff works?
No, Drummond, I think we can proceed to the next one.
Good, okay. Usually it's the next one that starts the questions flowing. All right, so what I'm gonna do here, whoa, I got something. Wait a minute, I've got something's in the, oh yeah, sorry. I got a out of order slide here. I was just moving some slides down right before this. So this is the same trust triangle. I call it the Tinker Toy version because I'm gonna step us through it. In fact, yeah, that's all right. I might have a slide missing at the very end because one ended up in the wrong place, but that's okay. So here we have issuer holder verifier, and you can see I've got verifiable credential on one side and proof on the other, and I'll explain that in a minute. And down here you see the component we call the verifiable data registry. Now that's a generic term for a good reason. Blockchain technology is obviously one good choice there, but it's not the only one, and I'll explain why. It's any system that can be used to provide the cryptographic verification these two parties need, and this is the basic way it works. An issuer who wants to start issuing digital credentials, not just physical credentials, and we'll use the example, to make it, the travel example here. Let's say it's a government agency and they say, we issue a passport or government ID card today. We want to start issuing the digital version. They write a DID to a verifiable data registry, and the associated DID documents, is the name of it, has the public key and the other cryptographic metadata necessary to support the process we're going to go through up here. So what is that DID? The decentralized identifier is the address of that DID document on that verifiable data registry, be it a blockchain, distributed ledger, distributed file system, any system that ultimately will be trusted by the issuer and the verifier to verify that key. You could even use a conventional certificate authority if you wanted to, but the whole point of decentralized identity is you don't have to rely on a single point of failure. So that's that first step. The issuer creates the key pair that's behind that and then writes the DID to the ledger together with the DID doc for discovery and verification of the public key. Now, with the private key, the issuer is now in a position to sign verifiable credentials that are issued off ledger to holders that go in their digital wallets. Now, the holder is in a position to present a proof of that credential to the verifier. And the reason we call it a proof is because they don't necessarily have to present the whole credential. It's not like you're going to a bar and you got to get out your driver's license and say, yeah, here's the whole thing. And the bartender's seeing a lot more, or the bouncer seeing a lot more than they need to. So there are three major credential signature formats supported in the W3C standard. I'll just tip them off. There's the JOT format, JSON Web Token. There's JSON LD signatures, and then there's zero knowledge proof signatures. Technically, it's Kamenish Lisenskia. And the reason for those three is they couldn't agree on just one because of the different trade-offs and benefits. But the important part is all of them support some level of selective disclosure of what's on a credential. And obviously with the ZKP format, you have very powerful selective disclosure capabilities. And I'll point out to this crowd, it might matter. This holder could have 30 credentials in their wallet and produce a single proof to a verifier. A verifier can make a proof request, and you can prove a single proof in the ZKP format of any claim from any credential from any issuer in that wallet. That's one of the reasons that I'm a big proponent of the ZKP credentials. So in any case, when that proof comes across, it has the DID of the issuer, so the verifier not only knows who it is they're trusting, but they can take that DID and read and get the current public key and the other metadata, including revocation information, if it's a revocable credential, and they can then cryptographically verify the credential. And as long as the verifier trusts the issuer, and there's a whole bunch of ways that can happen, we'll talk about that, then bingo, you've managed to transfer that trust. And the important part about it is no integration at all between verifiers and issuers. We're not in federated identity land any longer. All right, we've gone over the rainbow, and now verifiers, if they simply support verifiable credentials, it's a matter of, whatever credentials they'll accept, the proof requests they need, and any holder can come from any issuer, as we standardize the protocols around them. So this is the core. Now I'm going to walk quickly through one example of that doctor's passport, and then we'll stop and take questions. This again is the NHS example I gave earlier. We've got the issuer is the NHS. They are actually writing specifically in production today the sovereign blockchain. It's a public permission ledger based on the Hyperledger Indy code at Hyperledger. And this blockchain has been running for just over 3 years, and it's got about 75 we call them stewards, node operators around the world, and so it's being used for production credentials today. So they write their DID document. Now it's the doctor's passport they'll sign as it's issued to doctors or nurses in the NHS system. They can now produce a proof of that licensing credential to any verifier, such as the hospitals that they need to move around between. The hospital will use the DID of the specific issuer, and I'll talk more about the federation of issuers there, and they'll read that off the ledger and verify the credential. And again, all they need to know is, okay, that the DID for that issuer within the NHS system is valid, bingo. They're done, and provided the license meets their needs, that's how it works for the NHS. So I'll stop there on this picture and say, do we have has this elicited any questions?
Yes. So one question is, how do you establish trust between the issuer and the verifier? How does the verifier trust the issuer?
Got it. So there are two parts to that answer. I'm going to give the first part now, and then just ask to wait for the second part coming up that I'm going to go more deeply in. And the first part of the answer is there is nothing, zero, in the verifiable credential specification that answers that problem, because I invite you to ask the same question about a physical credential. Meaning, if I walk up to a verifier, let's say a TSA agent at an airport, and I want to get on a plane, ask that question, well, how does the verifier know they can trust the issuer? The answer is, they've already got a whole, I'll just use the term governance framework, around what credentials they will accept from what issuers to let you get on that plane, right? It is an out of band question from the standpoint of what their policies are, right? And for TSA, it's government issued credentials. It could be a driver's license, it could be a passport, it could be, it's written down, right? It's actually, I think in the US and various countries, it's regulations, what issues are trusted. Now, if I go to the other end of the spectrum and it's a coffee shop, like a Starbucks someplace, and what they're asking for is a loyalty card, well, it may be they only trust themselves, right? The spectrum can be any place in between. I like to use the example of a university. Let's say the issuer is a university, and what they're issuing is a student ID to a student. Well, who's going to verify that and why? Well, all throughout the university system, all the departments and, and applications and everything there, they're all going to go, yeah, we know the DID of this university. But then what about the shops and merchants in that town? They're all going to say, hey, we offer student discounts. If they don't know, they're going to turn around and learn the DID of that university, and then the university is going to publish it on their website. There's going to be various ways to discover. Yes, you lock in just like you would know the name of the website in a TLS certificate. You're going to know the DID of the issuer. Now that's the sort of basic way. The much more advanced way I'm going to cover in a minute. Any other questions?
So that means there should be a way out of band somehow. The verifier should know the public key associated with the signature.
No, it's not. It's not the public key. It's just the DID. And one of the reasons, so the DID will always get you the public key, and the most important thing, it will get you the current public key or the public key that was in use at the time that credential was issued. And you will be able to verify also using this infrastructure whether the key or the credential was revoked. So all the things that certificate authorities do today, what we've done is we've said, okay, now we can decentralize them, automate them, and cut the cost down to, not zero, but very, very close to that.
So so the public key of the issuer is associated with the DID document, which is once again associated with the DID of the issuer. So verifier needs to know the DID of the issuer.
Right, and the DID of the issuer is in the credential, just like if I got a state of Washington driver's license, it says state of Washington, right? And that DID of the issuer is passed through in the proof so that the verifier knows exactly, who the issuer is and how to look up and verify the public key, the revocation registry, all the data associated with the issuance of that credential. That's how they do their verification.
Yeah, so we
cryptographic verification. Go ahead.
Question from Abhishek. Does issuer need to host DID resolving?
No, technically the issuer doesn't. The issuer will need to write the DID to the ledger, but that doesn't mean they need to offer any DID resolution services. The verifier is who's going to need access to DID resolution. And DID resolution, if you understand DNS, you've got the basic picture of DIDs, but the deltas between the two systems are actually quite significant. It's not just that DIDs are decentralized or that it's much flatter because it's not hierarchical, but there are other important security differences between the systems. We probably don't have time to go too deep into that, but definitely the DID specification at W3C we're less than 2 months from being at what they call candidate recommendation, which means basically done. It won't be completely finished until September of next year through all the approvals, but a lot of information there, and we are working on an implementation guide, and a lot of information about DIDs in the Manning book. The DID chapter, which is already part of the early access, highly recommend it. We go deep into DID infrastructure.
Yeah, another question from Subham Kumar. Does holder at any time decrypt the encrypted data to show specific proof to verifier?
So the holder has the ability, again, this varies a little bit with the 3 types of credentials. The holder will always have the ability to see what's in the credential themselves, right? If it's been encrypted, and I say encrypted, the digital signature applied to the credential applies to all 3 formats. In the JSON-LD and JOT format, it's been put into that format, but the holder can read the data, you can display it, look at it in your wallet. That's also true of the ZKP credential format. The difference is with the ZKP credential, the holder can do selective disclosure of any attribute in the credential. So when the proof request comes into the holder in the wallet and what we call the agent there, the agent can look at the credential and surface in the UI, hey, this is exactly what you're being asked to disclose. Do you want to do that? Do you want to share that? So yeah, the holder has access. Now, with the ZKP credential, the powerful thing is only the holder can produce a proof of that credential. You can't, it's tied to what's called a link secret inside the wallet. Whereas with the other two credential formats, the holder has to have a public DID, and they're going to sign a proof with a public DID, and that has some correlation issues we'll talk about in a minute.
So yeah, so basically those are different models, right? I mean, so can there be a case that holder just share the credentials he got from the issuer without any like proof of possession?
You could certainly, yes, you can do it without any proof of possession. That's not a use case. I have not heard of a need to do that yet, but I'm not saying that certainly would be supported, because that's easy. You just literally are passing it through the holder. If you don't need to tie it. Most people are concerned with the other direction, which is how do I strongly bind that only that holder can present that credential?
So in that case, so holder has to have a DID, and the verifiable credential will have the DID of the holder too. Then basically you need to sign some challenge. The holder needs to sign some challenge with the key associated with its DID.
So let me go to the next chapter here, because we're going to talk about that. Now, I'm just going to say right now, that's one way of doing it. It absolutely can work that way, but it's also got a serious privacy problem. So let's talk about peer-to-peer connections and that whole thing of authorizing the holder, binding to the holder. Okay, so I want to point out that we have talked so far about what only we consider public DIDs, meaning DIDs written to public ledgers, what we'll call public utilities. And certainly a holder can do that. A holder could have a DID. And if they have a DID, then just the way the issuer signature can be verified, the holder can sign a proof. And you can verify, oh, that came from that holder, okay? And the issue there, I just want to be very clear, is if you think you're being tracked by tracking cookies, third-party tracking cookies today, imagine that you have a public DID, and every single time you share that anywhere, you are being absolutely correlated to that public DID. That is not a privacy scenario that I think anyone wants to get behind, except maybe, I don't know, there might be certain governments that would say, oh, that's wonderful, or certain companies that would say that's wonderful. But that, I'm just going to tell you, as a privacy by design person, that is a nightmare. And yet there are folks pursuing that out there. And by the way, if the issuer and the credential is for an organization, or maybe for a thing or a product, it's not a problem. But if it's an individual, if they're using a public DID to sign all of their credentials, and that means sharing that public ID with every verifier, that's, I mean, we're worried about sharing government IDs today, that's going to be even worse. Their public DIDs are unique for all time. So having made that point, let me explain how privacy by design works at this. There's another category of DIDs we call peer DIDs. And when this relationship is created here, the holder and the issuer each generate key pairs for the other, and then they share the DID and the public key, the DID document, with each other pairwise. It's the DID equivalent of Diffie-Hellman key exchange, right? It actually is. There's a protocol for it, the peer DID protocol, for establishing that. And once that's done, you have this permanent, secure, cryptographically verifiable channel between those two that they can use for any communication they want. Obviously, for issuing credentials or issuing revisions to credentials or making queries about credentials or whatever, but that's just the start of it. This is a permanent private channel between those two parties. And when the holder goes to the verifier for the first time, that's an entirely separate one with a different pair of DIDs. So if you're using peer DIDs and you're forming relationships this way, you can see that your wallet is not just a place to put credentials. It actually becomes a cryptographic address book for all of your relationships. And you, and only you as an individual, control that. It's not Facebook, it's not someone else with your social graph, it's you and all your applications that have access, that you give access to that wallet, can now access those relationships. But you're the controller sitting in the middle of that. Now, why is this important? And I haven't even talked about ZKP and link secrets yet. I want to make sure it's clear. Just this architecture means that everything above this line takes place off-chain, and it's fully GDPR compliant. If you have a holder writing a DID to a public ledger with a DID document and the private and the associated public key, that's personal data under GDPR. And I can tell you this with like 18 months worth of work on attorneys and regulators about that. And you have no right of erasure. I mean, it's a permanent immutable public ledger, right? It doesn't, so there's a real issue. And that's just a DID and a public key, let alone revocation information or anything else. You want to make sure that all the exchange of verifiable credentials takes place off ledger, takes place under private relationships. This holder not only has pairwise peer DIDs that they can delete these relationships at any time, fully GDPR compliant, but from a GDPR standpoint, the holder can produce a verifiable request sent over this channel to either one of these parties to exercise their right of erasure and ask for the data to be deleted. And that request can be logged and is cryptographically auditable on both ends of these connections. So SSI is really the a GDPR. It's mana for GDPR compliance for companies, institutions, organizations of any kind, and it's a power tool for holders to control those relationships. And you can see right here that one option you have is for to verify the holder now is for once this relationship is set up, if the proof is going to come over this channel. So all the messages are digitally signed by the holder. So the verifier already knows that it's dealing with the holder when the proof comes across. You don't need a separate signature, and you don't need one that involves a public DID. So I know I've given a little longer explanation of that, but it's because of that last question. I hope this is clear. So I'm going to stop again. Any questions here?
Yeah, there are two questions related to link secret. So I'll ask both the questions together. First one, when you talk about link secret, is that stored anywhere else other than with holder, as in, let's say, holder lost his phone? The next question, does the link secret in the wallet prevents the person, merchant, reader from stealing the deed? Is that correct?
So I'm going to take those in order here because the second question is a little harder than the first. So let me now, even though I don't have separate slides, let me talk about the link secret approach. So the peer DIDs that are set up on a again on a per relationship basis, and the associated key pairs that go with them, they're stored by the holder in the wallet, but they're not associated directly with the link secret. The link secret is used as one. I mean, there's not a technical limitation, but the whole point is the holder has one link secret, and the protocol is for Commercial Licenski and other forms of zero knowledge proof credentials, is the holder when they're requesting a credential from an issuer, the holder produces a blinded version of the link secret. They basically do a derived link secret they can prove came from the one they hold. They never reveal that to anyone. The blinded link secret goes to the issuer. They bind that into the credential that's issued back to the holder. And now when the holder produces a proof of the credential, they also produce a proof that they control the link secret. That's why the holder is the only one who can produce a proof of that credential. Now that link secret is stored in that wallet just alongside those the key pairs for all the peer DIDs and obviously any verifiable credentials, which means that if you can successfully steal the entire wallet, you can gain control of that wallet. But that's what you have to do, is you have to steal the entire wallet. So as soon as you, of course, have that much power in a digital wallet, what you have to have is strong, easy to use, and largely automated backup and recovery. And I have a whole separate set of slides that I could do on that, but I can share. Actually, you can find it very easily if you look up Hyperledger DKMS for Decentralized Key Management System. You'll get a 70-page paper that explains the automated backup and recovery options, either offline or what we call social recovery, for being able to maintain a continuously backed up encrypted version of the wallet where the recovery key is either offline or sharded among several trusted relationships, so you can get it back and recover it if you lost the phone, if it got corrupted, whatever else happens. So that was the first question. Now I forgot the second one.
Yes, the second one is, does the link secret in the wallet prevents the person, merchant, reader from stealing the deed? Is that correct?
No, the link secret, as I said, the link secret is in the wallet together with the peer DIDs. And if there were any public DIDs, all the private keys would be there. So if you could successfully steal a wallet, then you would have access to that. But there's a number of ways to protect against that as well. Obviously, one of the things, in fact, I'll just go quickly and talk about this. Everyone asks, well, where do biometrics fit in SSI? And the answer is they fit almost any place they do in other forms of identity access management. One of the obvious ways that we use biometrics today, fingerprint or face scan, is unlocking the wallet, right? So all of us, it's just Apple, Google, they've gotten pretty good at saying, hey, you want to protect your smartphone, all of it, use biometrics to unlock your wallet. And therefore, if someone steals your phone or you lose your phone, you're not exposing that information. Again, if you have a continuously maintained backup, then you literally get a new phone and restore your wallet and away you go. But this is, I want to point out, there's actually 4 different ways you can integrate biometrics. Daniel Hardman, the chief architect at Evernym, is working on a paper on this. It'll be released shortly, and I'll just quickly bullet point them. You can, what I just explained, unlock the wallet. You can add a liveness checking function in the wallet to do, real-time verification, for instance, of a facial scan. If the verifier needs to know it's really you in front of that wallet right now, you can actually bind biometrics into a credential if you need to, such as a picture, which requires the verifier to do real-time verification. But that is, of course, how physical credentials work. And lastly, the most powerful, but it's taken the longest time to work out the privacy, is remote biometric verification from what we call biometric service provider. There's an entire IEEE protocol for that. Trying to remember what the name. It's called the Horcrux protocol, named after the Harry Potter story. So if you're interested in that, just Google Horcrux protocol. You'll find the word in the Harry Potter dictionary, and you'll get the protocol for using a biometric service provider. So those are all ways of basically both binding it to you, but also protecting it, because if the wallet requires a biometric, then even stealing the wallet is not actually going to help you. Does that help?
Yes, there's one more question. What we know about this public DIDs, so they can be resolved to a DID document. So given a DID, you'll be able to resolve like which blockchain you have that, and then find a DID doc.
Yes.
So how does that work with private pairwise DIDs? Are there any DID document behind a given DID, and
yes.
are they resolvable?
Yes. The thing about pure DIDs is they're just the regular DIDs, right? They absolutely are fully conformant. It's just that they are generated entirely in the respective. I'm only showing a digital wallet here for the holder, but in fact, these are just roles, and all 3 of these will have digital wallets. In this case, the issuer generates a key pair and then generates, with pure DIDs, you generate the DID from the key pair. Simple way to put it is, obvious options, hash of the public key. The initial, now keep in mind, part of the reason for DIDs is to solve the problem about how do you maintain continuous identity, cryptographically verifiable identity, while being able to rotate keys. And so the trick is always, how do you maintain, not how do you generate the initial DID from the first key pair, that's fairly easy, but how do you then keep it associated, the same DID with keys as you rotate them? And the answer with pure DIDs is, I'll actually back up to that just so we have it right here. Oops, right there in front of us, is the 2 parties generate the key pairs and the DIDs, and the DID documents basically has that and what we call the service endpoint, and shares it with the other one. That's the pure DID exchange protocol, and the reverse happens here. Again, like I said, it's the SSI equivalent of Diffie-Hellman key exchange. Once that's done, the relationship is set up. They each have their other DIDs, and they never need to change those for life, and in fact forever. They're 128-bit or whatever the peer did protocol. I think it is it's either 128 or 256 bits. So essentially, they've just generated DIDs that are not on a ledger. They're just shared with the two, and they DIDs and DID documents. And so from that point forward, what happens is, let's say the holder rotates a key on this relationship. They send a signed message and a signed version of the DID document to the issuer. The issuer will verify, yep, that's an update. They'll update their DID document, and they're in sync, and vice versa, for as long as it needs to happen. Does that help answer that question?
Yes. So one last question for this section.
Sure.
So which specification defines the communication protocol between these entities? Like which protocol is it? TCP, or what the protocol between how they communicate with each other?
Really, really good question. I'll answer it quickly, and then I'm going to get more of that in the TCP/IP stack. The actual peer DID exchange protocol here is called the peer DID protocol, and it's come from the peer DID specification, and it's now at the Decentralized Identity Foundation in the Identifier and Discovery Working Group. So I think you can just, if you want to Google it, just put Decentralized Identity Foundation peer DID specification, PER, this right here. And you'll get to it. The author is Daniel Hardman, Hardman. Well, there are about 15 contributors now, but he started it. And that will give you the protocol for doing this. Now that is now being subsumed into DIDCOM, and I'm going to talk about that in a minute.
Sure.
Okay. All right. I want to make sure I know we've got about just about 20 minutes left. I've got two more topics to cover here to sort of complete the full picture here. I want to make sure that it's clear in the adoption of this infrastructure, which I think hopefully you're getting a picture. It's like, whoa, we're not in Kansas anymore, right? You want to talk about identity access management. It was centralized, and then it was federated, and we're like in the third generation of federation. And what I'm telling you is it's like all that was pre-internet, and then along comes the internet of identity. I mean, decentralized, peer-to-peer, it's a superset of everything before. Well, in that superset, there is a very special role for governance frameworks. This is not technology. This is how we actually get the technology to work in the real world. And the classic question you can say that, it's the question was asked, well, how does verifiers know all the issuers? A classic example is take an employer that wants to, it's accepting or interviewing an employee, and they're doing their due diligence to say, well, can you give me a verifiable credential of your educational credentials, right? Your high school diploma, your college degree. Well, how are verifiers supposed to know all the accredited high schools and colleges in the world, right? The answer is you add a second trust triangle. We call it the governance trust triangle, and this role is called the governance authority, and they publish something called the governance framework. And if you're wondering, well, really, how does that work? Well, go back to the wallet you carried today, and and you almost certainly have in there either credentials from MasterCard or Visa. They're the governance authority, and they authorize all the banks and credit unions in the world to issue a credential called a credit card to card holders who provide proofs of that, as in, a swipe or whatever, to merchants around the world. And why do merchants trust that? It's because they trust the governance authority. They neither need to know all the banks out there, and the banks don't need to know anything about the merchants, because that's what this governance framework, governance authority, and what we call this trust community handles. So they've already built one of the largest trust networks in the world, and Visa has one, and Discover has one. But what we're doing with SSI as a whole is we're saying, oh, any trust community of any size can do this same thing, can have a governance framework, whatever governance authority. Don't think just government or industry consortium. It can be a university, it can be a city, it could be a church, it can be a neighborhood, it could be, whatever. All they need to do is basically say, what credentials do we need? Who can issue them? Under what policies? Publish it out. And now verifiers, this can be on a website, and verifiers can go and go, yeah, I've heard about that. Yeah, I'll build I'll build into my policy about what I'll accept. And the governance frameworks, by the way, will actually publish proof requests, as in, this is exactly the set of questions that we're designing our governance framework to answer for you, Mr. or Mrs. Verifier, right? Here are the proof requests. And so the verifier doesn't have to do anything more and go, so you can answer age over 18, or college diploma, or high school diploma, or previous employment, or whatever it is, right? And they build that in, they publish those proof requests, and now the whole system produces what the answers that they need, okay, as verifiers. Now, the other example I gave you earlier, we're talking the doctor's passport. Well, we've got the governance authorities, NHS. The issuers are all of their hospitals. They do delegated issuance. They're not going to be a centralized for all the doctors and nurses. So they can now issue that staff passport, and any hospital or within the system or anyone else will be able to verify it. And I'll give you a third example because I keep talking about it, Internet of Education. There is a whole bunch of folks working together on something called IOE that are establishing overall governance that will be able to answer that question: what's an accredited educational institution anywhere in the world? And it's coming together slowly, but that's what they're all recognizing is now possible, because then they can issue any credential to a learner, and anyone like an employer will be able to ask for that and verify that the DID is recognized by the IOE. And you can see that one of the classic service of governance authorities to maintain what we call a member directory. They can do it on a blockchain or any other system where they can basically say, here's the DIDs of all the issuers that we recognize, which are very, very long-lived. So that's the role of governance frameworks. I'm going to stop here for the last chapter on the Trustworthy stack. Any questions about this?
No questions so far. Yeah.
And we have, according to my, we have 14 minutes. Is that right?
Yeah. Yeah.
Good. Okay. So I'll be able to get through the last part here, and then we can just cover all the questions that might. Okay. So again, I wanted to make sure this was clear, because as these components have come together, and SSI has gained this momentum for the the set of the breadth of the internet identity issues that it can solve, it's raised this question. It's like, okay, we got like verifiable credentials of W3C, but that's only the start of what we're going to need to do to standardize interoperability for this. So a gentleman named John Jordan, who is the executive director of the Digital Trust Service in the province of British Columbia in Canada, he said, this is turning into a stack, and we recognize this stack I'm about to show you, but he had the insight to say, wait a minute, this is the stack for digital trust that the TCP/IP stack was to the internet, to data exchange. And so he came up and he said, oh, this is sort of like, we had the internet and then we figured out how to do voice over IP, right? And now we're doing things like Zoom, right? Voice and video over that, and that became WebRTC. He said, this is doing trust over IP. We're doing trust at a distance, right? We're taking all of this, and so he named this a trust over IP stack. And the term caught, and one of the reasons it caught is because it really was becoming clear. And this again, there were a bunch of us that began working together saying, wait a minute, we have a 4-layer stack here that's got a fascinating architecture. It's very clear, and of course, classic architectural layering, why it's 4 technology layers. But the aha was the governance frameworks actually need to exist at all the 4 layers too, because what you're governing under each of these governance frameworks is what needs to happen at this layer. So just as the layers build on each other up to the application layer at the top, so do the governance frameworks. And when that aha hit and we broke it into the governance and technology stacks, suddenly, bingo. And that happened about, we first started working on a stack about 18 months ago, and this aha came about a year ago, and that turned into the momentum of the foundation I'm going to talk to you about. So I'm just going to walk you up the stack here. Layer 1, the public utilities, we're talking about verifiable data registries. We call them the ones that are operating publicly. Things like sovereign, but the permissionless, Bitcoin, Ethereum. There are, by the way, sovereign uses Hyperledger Indy. It's the best known network today. There are 6 more that are in progress of being developed right now around the world. One of which, called ID Union in the European Union, is already operational. It's still in a very early phase, but I think it will be in full production, probably by Q1 of next year. And that's a planned SSI network for the entire European Union. It's like take sovereign blockchain and say, okay, we want to do one just for European Union, so that issuers can use that for the things they want, to be trusted in the EU, or the DIDs they want. Each of those, of course, has a DID method. That's what provides the abstraction for all that. Governance for layer 1, if you have a permissionless network, your governance is in the code, right? If you have a permissionless blockchain. If it's public permission like sovereign, then you have a governance framework. In fact, the most advanced governance framework that's out there for this stack is the Sovereign Governance Framework, SOVRIN. And if you want to look at that, just Google that term. It's absolutely going to be at the top of your list. So, and these, by the way, are 3 standard roles in that. Transaction authors write the transactions, endorsers actually process them. It's again, public permission, so you have to go through an endorser, unlike with permissionless. Stewards are what we call the folks that run the nodes. Those are just examples as I go up the roles we have here. So that's layer 1. Layer 2, surprise, surprise, it is the agents and wallets, and the ability to form the connections and exchange peer DIDs. That's the standard DID at layer 2 versus public DIDs at layer 1. And the protocol for these connections, and again, the peer DID protocol has now been subsumed into, is called DIDCOM, DID to DID communications. That is being standardized at the Decentralized Identity Foundation in the DIDCOM working group. Several, the Hyperledger community, DIDCOM, W3C credentials community group, all got together and said, let's create the specifications there. And so if you're interested in that, that group meets weekly, super interesting. DIDCOM 2.0 is, I think, about 2 months from being mature. So that's how we get interoperable, portable, I'm going to hold up my phone and go, digital wallets that are not like the one that's the proprietary one that's built into this phone. But hopefully, I mean, you can get, there are about a dozen out there already that you can get. At Evernym's is called Connect.me, but there's Satis in Germany has one, Trinsic, Matter. There's just a bunch more of them out there if you want to go start playing with them. But the difference is open standard, interoperable. You can move from one wallet to another, and you'll never be locked into the wallet the way you are on these phones. Okay. Layer 2, the governance we need is around things like that: interoperability, security, privacy, all that stuff. Layer 3 is what I've already explained: the trust triangle, the credential exchange, and the different data exchange protocols we need for doing that. Again, DIDCOM actually, DIDCOM is the enveloping protocol or secure messaging protocol, and there's several protocols for exchanging the different kinds of credentials. Both the DIF and W3C and Hyperledger all working on those. Credential registry governance is exactly the kind of thing that MasterCard and Visa do today for credit cards. And there are now dozens of credential governance frameworks that are being developed. And the top level is whole ecosystems now of applications, like the Internet of Education that I talked about, or healthcare, or travel, where all of the members of the ecosystem want to rely on a standard set of credentials at layer 3 that are interoperable layer 2 and use trusted utilities at layer 1. This is where you really deliver the value, and where you're going to have services like the member directories I talked about, auditing and audit accrediting, trust marks, kinds of things that will surface right up to the application level. This is the trust over IP stack. And before we get to the final set of questions, I'll just quickly say this and the tremendous benefit we get from standardizing and hardening this both has the TCP/IP stack for the internet is only a technical stack. If we want to have a trust layer for the internet, we need the technical stack and we need the governance stack. The models for how to do this, governance authorities around the world, thousands, millions of governance authorities of all sizes can create the governance frameworks they want for their trust community, and individuals, organizations, and things can all use that infrastructure and create transitive trust. And to pursue that vision and to be able to use this as a tool for creating that, that's why we created the Trustworthy Foundation. It was launched in May. It's a Linux Foundation project. It has what we call open participation. Any individual or organization can join and be a member at no cost. You can join as an associate or steering member if you want to, have your logo up and be part of the steering committee. But we started with 27 member companies, and we have passed 125 now in about 5 months. So I just want to make sure everyone knows that's listening to this. You're more than welcome. We'd love to have you there. It is, again, pulling together all of the standards and open source efforts that are coming into the interoperable stack. And the last slide I have here is these are the 4 major working groups: the technical stack and governance stack for building those out, and then what we call the Foundry working groups. If you want to create either a utility layer 1 or an ecosystem layer 4, that's where we saw the most activity. We will probably create Foundry working groups for layers 2 and 3 over time, but we started with those. These working groups are all now meeting, most of them bi-weekly, and we have Slack channels and mailing lists, and it's happening. And that's it. We've got 5 minutes to take another round of questions.
Yeah. So one question from Michael. Can you highlight the difference of this from the PKI CA structure?
Oh, that's a great question. All right, I'm gonna pop back to go to a second. It's usually easiest to bring this up during the questions, and I should just stick the slide in the end so I can go right to it. Okay. I'm going to just try and boil it down to 3 key differences, and I mean important differences, not just key differences. Okay. The first one is at layer 1. It's fundamental. The fundamental difference is moving from single points of failure, the current CA system. And I'm not saying CAs are, I'm not throwing any stones at CAs. In fact, some of the largest CAs in the world are very active on building this infrastructure because they see it's where it's going. It's just inherent in the way conventional PKI works, is that your root of trust in your, that you're working from is a digital certificate. And it's actually the certificate of a CA. And so the current X.509 PKI that we're using for the web, right, that's powering HTTPS, and the lock in your browser, that is determined right now. The roots of trust are roughly 200. It's between 200 and 240, I think, CAs around the world whose own certificates are built into the browsers we use, right? So there are 5 browser manufacturers in the world that decide about that, and 1 organization, Web Trust, that actually audits those CAs. So it's good, but is that really the future of trust on the internet? Is we're going to rely on 5 browser manufacturers to decide who the CAs are? And it's a very centralized system, very subject to single point of failure. It's also, expense has been going down, but it's expensive, but it's a lot of friction. And so the number 1 biggest difference with PKI is that with Trustworthy layer 1, there are going to be a host of these utilities, and getting a DID, a public DID, should be something you can do out of a piece of software in less than a second, right? And the cost should be, well, it's just going to go down and down, but it's going to be an order or 2 orders of magnitude less effort than having to go get a root certificate. I mean, a X509 certificate from a CA. So that's point number 1. Okay. Point number 2 is, I'm going to go up to levels 2 here. The support for DIDs being built into these means that it won't be the exception that you're going to have a certificate like, now more and more websites are supporting, saying, hey, HTTPS by default. But that's to do one thing, which is encrypted connection with the website. It's not for, signing documents, or, in other words, today we are using conventional PKI for specific things versus building it right into the infrastructure. These agents and wallets, 100% of what they do is encrypted communications based on peer DIDs or public DIDs, right? So that's the second major difference, is we're just building it everywhere. Now, the third one is profound, and I know we're running out of time, so I want to try and make this point. What we've done here by separating these layers is, today a certificate authority will take a name of a real world entity and bind it to their certificate. Say, yeah, that's really, that's really Microsoft, and that's their domain name, right? It's a human making that. With this infrastructure, we have separated verifying the cryptographic identity, meaning the DID of an entity, and anything about the real world attributes, their name, their web address, their real world address, their logo, everything about them can now be communicated in verifiable credentials that can be issued by all the entities on the internet, not just certificate authorities. So what we've done is we separated cryptographic verification from real world identity attribute verification, which can now be done with verifiable credentials in a much more robust and frankly democratic way. That is really what's going to unleash the power of a digital trust ecosystem. So I'm sorry, that's sort of a long answer, but you asked a very deep question, which by the way, we go into in great detail in the book.
Yeah.
Other questions, or are we out of time?
Yeah, we'll take up two questions. Is it okay with you?
Sure, no, that's fine. I'm good.
Yeah, is there a government agency that oversees this? Like in case of MasterCard, it may be the Department of Treasury or CFBP, etc.
So my answer there is you will have government agencies. It's a little bit like saying, is there a government agency that oversees the internet, right? Well, in fact, in most countries, there are government agencies that actually do look at the health of the internet and what needs to be, governed within their country for interoperability and safety of the internet. Absolutely, you'll have government agencies that will be involved, and in some cases, they'll be publishing governance frameworks, like for their citizens. Great example today, Canada, which is a world leader in digital identity, has been for like 2 decades, has the Pan-Canadian Trust Framework. The architects of that framework, I was on a signal message with one of them this morning. They love the Trustworthy stack, and they want to evolve the Pan-Canadian Trust Framework to be one of these, a governance framework for the whole of Canada that will actually turn around and say, here's the rules for all the Canadian provinces to all issue government IDs that are verifiable credentials that you can use in that province, between those provinces, or anywhere in the world. So you will get governments directly participating. They will be publishing governance frameworks, and you'll get private industry, and you'll get education, and they can all interoperate. So I think, and you will also get, and we're already seeing governments that say, we want to run a public utility. I'll give you another example, Finland. Finland has a project called Finnish Indy, where they're planning to run a Hyperledger Indy blockchain just for layer 1, just for Finland, because they want to consider it critical infrastructure. So I think a lot of folks call this whole Trustworthy stack, it's going to empower RegTech, right? Regulation technology. And some people will say that's good, and some people will say, oh, that's more regulation. I actually think it'll be good because it'll allow effective regulation with the least friction on the market.
Yeah. So the last question, is it a must to have a blockchain for the verifiable data registry? And if we are to use a blockchain, why do we need to pick blockchain for that?
So the answer is very simple. It is absolutely not a must. That's why I pointed out, you don't actually see the term blockchain on the Trustworthy stack. And even in the specifications, you see the term verifiable data registry. Whatever will be trusted by issuers and verifiers to anchor public DIDs at layer 1 will work. And there are, when we started to work on DIDs 4 years ago, we thought, maybe we had the whole concept, you need these DID methods to adapt DIDs to talk to specific verifiable data registry, whether it's different blockchains or distributed databases like IPFS. And so we said, hey, you can design a DID method, and here's how you do it, and you can plug it into a resolver, and it's all wonderful. Well, we thought that maybe, we get to a dozen or so, and there are already over 60 that have been registered with W3C. And then we're putting into what's called the DID spec registries. And I expect that by the time the spec comes out, it'll double again. So all kinds of options are going to be available. Any backend system you would trust. Microsoft, for instance, has developed a whole open source, it's called SideTree. It's a middleware layer that you can bind to multiple backend distributed ledgers or blockchains. ION is anchored on Bitcoin, but it will work across all of them. So, and there's the last thing I'll say here, because I just got to put a plug in for it. Check out KERI, K-E-R-I, Key Event Receipt Infrastructure, because it's a whole architecture coming from Dr. Sam Smith, who has been very involved with Sovereign, but a bunch of other projects, and Ethereum. And it's basically the first truly portable DID method that will work across all of them. So absolutely, you do not need a blockchain. It can be big or small, or it can be private or public. It doesn't matter. As long as it's trusted by issuers and verifiers, it's going to work.
Is there an advantage in using, let's say, like Indy for that, Hyperledger
Well,
Indy?
the one thing I will say about Indy is it's the only blockchain that has been designed from the very outset to do just this, right? It's not, there's no cryptocurrency, there's no there's no other land use records or anything else. It's just designed to support DIDs and the other, like I said, revocation registry, the things you need for this stack. Which is why we're going from the one that's operating as infrastructure today, Sovereign, to 6 or 7 more in the next year, because they're all going to be running Hyperledger Indy, because it's designed for that. But let me be clear, there are methods for Bitcoin and Ethereum. Other Hyperledger projects, Fabric and Besu, have added DID support now. So and there's another method for IPFS that I think could be very popular. So whatever backend verifiable data registry you want to use, as long as there's a DID method, it should plug in, and all the agents and wallets should be able to use it.
So yeah, thanks a lot, Drummond, and it was a very informative session, and thanks a lot for taking all the questions and making everything very clear. And thanks everyone for joining in, and looking forward to meet you at the next meetup, probably in 2 weeks time. And thanks again. Thank you.
You bet. And again, IAW is coming up. If you're really interested, just check it out, internetidentityworkshop.org or com. I think either one works. And thank you, Prabhat.
Okay, thank you. Bye.